Okay, so let's talk about the JK flip-flop. The JK flip-flop has two inputs, J and K, the clock as well, and then the two outputs Q. So here would be the way this works. When J and K are both 0, right, and the clock comes by, Q will just stay what it was. It'll stay Q naught, meaning it'll stay what it was in the previous state. It's just going to stay the same. When J is 0 and K is 1 and the clock comes by, it becomes the clear, okay? And that changes J to Q. I mean Q to 0, excuse me. Alright? So then when it's J is 1, K is 0, that's when you set Q to 1 when the clock comes by. And then when they're both 1, that's called the toggle condition, and it will just flip the values of Q and not Q. Okay, so when they're both the same, it doesn't change. If they're 0, if they're both the same and they're 1, it toggles it. If J is 0, then it clears Q. If J is 1, then it sets Q. Alright, and remember that not Q is just the opposite of Q. Alright, so here we come by, okay, and you can see the various conditions. So again, every action takes place exactly at the rising edge of the clock, because in our previous, see, it's a triangle, so it's just a regular clock input, so it's a rising edge, and every transition happens there. So when we come here, we have K is 0, J is 1, the clock comes by, so it changes Q to 1. Here, J and K are both 1, so it flops the values. So that's the toggle condition again. Okay, so at the next rising edge of the clock, they're both still 1. It will flip-flop the values again. It will toggle the values. So Q will go back to 1. All right, when the next rising edge of the clock comes by, you're going to have K is 1, J is 0. So that's the clear condition. And Q goes to 0. Then here at this line, you can see that K is 0, J is 0. That's the no change. Everything stays like it was, so Q stays 0. Then we turn J to 1, K is 0. That's the set. So when the clock comes by, it's going to change Q to 1. And here they are both 0. J and K are both 0, and so it's the no change condition. All right. And you have to have that table to tell you what's going to happen to Q. You have to have the excitation table to tell you what's going to happen. Remember, the inputs J and K are just switches, or they're coming from something else. So that is the JK flip-flop.